Hi there. Today's lesson is going to deal with finding the distance between 2 points, and we're going to use what we know about the Pythagorean Theorem to do it. If I want to find the distance between the point -4, -3, and the point 2, 4, I'm going to just call it D. I'm trying to find D for distance. Now, the easiest way to do that is to make a right triangle out of the segment that I have already there. If I look at that as being my hypotenuse, then what I can do is make a right triangle out of that and then use Pythagorean's theorem. So first of all, let's find out what these distances are. If I look 1, 2, 3, 4, 5, 6, 7, this length here is 7. If I count the distance here, 1, 2, 3, 4, 5, 6, that distance is 6. Now, let's look at this point right here, because I want to see where we can get the numbers 7 and 6 if I just look at the vertices of the triangle. This is the point 2, comma, -3. So if I look at the x-coordinates, if I look at this horizontal line right here, and I want to find how long that is, think back to when we had a number line and we wanted to find the distance between two values. Now, look along the x-axis here. I want to find the distance from -4 up to +2. So from -4 up to +2. Now remember, when we were doing number lines earlier this year, the distance between 2 points is the absolute value of a minus b. So in this case, it would either be the absolute value of -4 minus 2, which is the absolute value of -6, which is 6, or the absolute value of 2 minus a -4, which is also the absolute value equal to 6. So it looks like for the horizontal distance, because the y-coordinates are the same, I'm going to look at the two x-coordinates, -4 and a +2. If I subtract them, I'll get the 6. Okay, now let's look at the y's. It's the same type of thing with the y's. With the y's, I have the point 2, 4 and the point 2, -3. Notice that the x's are the same. So I'm looking at the distance from -3 up to +4. So let's do the same thing. If I take the absolute value of 4 minus a -3, that gives me the absolute value of -7, which is 7. If I take the absolute value of -3 minus 4, that's the absolute value of -7, which is also 7. So to find the horizontal distance, I took -4 minus -2, and to find the vertical, I'm going to use the other two coordinates. So to find one of the legs, I subtracted the x-coordinates and then took the absolute value. To find the other leg here, I subtracted the y-coordinates and took the absolute value. So now let's finish this problem by using the Pythagorean theorem, using 6 and 7 and D. Okay, remember that the Pythagorean theorem is hypotenuse squared equals leg squared plus leg squared. So in our case, D squared would equal 6 squared plus 7 squared. That's 36 plus 49. That's 85. Now if D squared equals 85, and 85 is not a perfect square, so the best that I can do is to say D equals the square root of 85. Okay, I want to look at kind of the generic general case. If I have 2 points, x1, y1, x2, y2, and I want to find the difference between them, I'm going to make a right triangle. And in this right triangle, I'm going to find the coordinates of this point right here, so that I can use that point to find my two legs. Now, if 2 points are directly on top of each other, they must have the same x-coordinate. So this must also be an x2. Now the same can be said for the y-coordinates. If I have 2 points that are straight across from each other, that means they have the same y-coordinates. So this point must have the coordinates x2 and y1. So to find the distance, remember from what we did in the last problem, this distance is going to be the absolute value of y1 minus y2. Notice the x-coordinates are the same, it's the y-coordinates that are different, and that's what we need to measure. And over here, the distance, the y-coordinates are the same, so I'm going to measure the x-coordinates because I want the horizontal distance. So that's x1 minus x2. Now let's see what happens if I call this d and I put all of that into the Pythagorean theorem. When I take leg squared plus leg squared, because I'm squaring this quantity, it doesn't matter if I get a positive number or a negative number when I subtract the x's or the y's. Because they're being squared, they will automatically be positive. So I really don't even need the absolute value brackets. So that's why the second step is written with just parentheses. Now, please, please, please remember that when we take the square root of both sides, or do anything to both sides, we have to do it to the full side. Please don't do this. You can't take the square root of parts of things. That does not work. Instead, you have to do the same thing to both sides. So I will take the square root of this side and the square root of this side. So I end up getting d equals the square root of this quantity. So for the distance formula, to find the distance between 2 points, you subtract the x's and then square it. Subtract the y's, square it. Add them together and then take the square root. That's how you find the distance. So let's look at another example with just the formula. Okay, we're going to find the distance between the point 5,7 and the point -1,4. Now I don't want to have to graph these points and draw the triangles and go through all that every single time. I have developed this formula that will do all that work for me. So the way it works is you subtract the x-coordinates, that's 5 minus a -1, and then I'm going to square it, plus subtract the y-coordinates, 7 minus 4, and square it. So what I get when I subtract my x's is a positive 6. What I get when I subtract my y's is a positive 3. So d is going to equal 36 plus 9, and that's all under the square root bracket. So I get d equals the square root of 45. Okay, now that's a great answer, but you should know from our study of radicals that that is not finished. I need to come over here and break it down. The square root of 45 can be written as the square root of 9 times the square root of 5. I know the square root of 9 is 3. I don't know the square root of 5. So my answer is actually going to be for this problem that the distance equals 3 radical 5. That's the distance between those 2 points. Okay, here's a triangle problem where we're supposed to find the perimeter of this triangle. Now, the perimeter is the distance around. In order to find the distance around, I need to find the length of each of the sides of this triangle. So for C, I find the distance between -1, 2, and 7, 1. So here's the work for C. Now, I can just go ahead and put up here that C equals the square root of 65. Now for B, that's the distance from 7, 1 to 3, 4. So notice in the subtraction that it has to be done carefully. You might get a negative number, like this is a -4. You might get a positive number. Over here, it was a -7, which was a -8. You know, just be careful in your adding and subtracting of positive and negative numbers. When I work out all of the work for B, I got a perfect square. So I can get 5 for B. So I want to now actually go through the other one with you. So to find A, I need to subtract 3 minus a -1, and that whole quantity needs to be squared. And then 4 minus 2 that is squared. So 3 minus a negative 1 is 4. So I've got 4 squared plus 2 squared. So A is the square root of 16 plus 4, which is the square root of 20. Now, I have got to come over here and do a little bit of cloud work because the square root of 20 can be broken down into radical 4 times radical 5, which is 2 radical 5. So my answer for this one is that D equals 2 radical 5. Now, I call this cloud work, but you can do it right from here. I just didn't have room here. So now when I look at my distances, I can put this one on here, A equals 2 radical 5. So the perimeter, so for my answer, the perimeter, which is P, I have 5 plus 2 radical 5 plus radical 65. Now, that is the final answer. None of those are like radicals, so I can't add them together. And unless you're specifically told in your assignment to use a calculator and come up with an actual figure, I want you to leave them in radicals. So, in summary, we have a distance formula that helps us find the distance between any 2 points. So, in the assignment for this week, you're going to just be practicing using the distance formula. And please make sure that you check at the end. If it cannot be simplified, you leave it. If it's a perfect square, you simplify it to the whole number. If it is a radical that you can break down and simplify, you must do that.